Okay, in the last class, we have discussed about that analytic function. Today we are going to discuss about that bilinear transformation. First you write the definition for bilinear transformation, then we can discuss the problems in bilinear transformation. Write the definition for bilinear transformation. The transformation the transformation W equal to AZ plus B divided by CZ plus D, where A, B, C, D are complex constants the transformation Z equal to the transformation W equal to AZ plus B divided by CZ plus D, where A, B, C, D are complex constants such that AD minus BC is not equal to 0 is called bilinear transformation. Is called bilinear transformation. It is also called linear fractional linear fractional linear fractional or Mobius transformation. If AD minus BC equal to 0, every point of Z plane becomes a critical point of the bilinear transformation. The term AD minus BC is called determinant of the bilinear transformation. So what is meant by that bilinear transformation is we are transforming Z plane to W plane based on some fixed points. Write the heading cross ratio property. It is so important. Cross ratio property of the bilinear transformation. Cross ratio property of the bilinear transformation. cross ratio property of the bilinear transformation. Write the heading. If the cross ratio of 4 points is invariant under linear transformation under linear transformation if W1, W2, W3, W4 are the images of Z1, Z2, Z3, Z4 respectively, under the bilinear transformation then W1 minus W2, W3 minus W4 divided by W1 minus W4, W3 minus W2 is equal to Z1 minus Z2, Z3 minus Z4 divided by Z1 minus Z4, Z3 minus Z2. You have to remember this formula. This is known as the cross ratio property of the bilinear transformation. It is known as the cross ratio property of the bilinear transformation. Next heading, fixed point of the transformation. Fixed point of the transformation. Fixed point of the transformation. If the image of the point, write the definition. If the image of the point is at under the transformation if the image of the point is at under the transformation W equal to f of z, is itself then the point is called fixed point. The point is called fixed point or an invariant point of the transformation. It is a MCQ question. What is meant by fixed point of the transformation or invariant point of the transformation? Problems. First we will do that MCQ problem. Then we can go for that long questions. First one, find the invariant point of the transformation. Find the invariant point of the transformation. Find the invariant point of the transformation W equal to 2z plus 6 divided by z plus 7. Then find the invariant point of the transformation W equal to 2z plus 6 by z plus 7. Now listen, if the problem is given like that, then you can see that fixed point or invariant point definition. The fixed point definition is that the image of the point z under the transformation W equal to f of z is itself, then the point is called the invariant point. That means write the solution for this. Simply we can do substituting or take W equal to z in the equation. Substituting or take W equal to z in the equation, given equation. So in case if you are substituting that W equal to z in the equation, that means you are taking W in the image as that z itself. That means you are substituting W equal to z here. So z equal to 2z plus 6 divided by z plus 7. So solving this, that means z into z plus 7 equal to 2z plus 6. So z square plus 7z equal to z plus 6. So z square plus 5z minus 6 equal to 0. So if you are solving this, what is the multiplication number? Minus 6. Addition number is plus 5. So what are the two numbers? Multiplication is minus 6. Addition is plus 5. What are the two numbers? Plus 6. So we can write that z plus 6 and z minus 1 equal to 0. Therefore z equal to minus 6 comma 1. Is that equal to minus 6 comma 1 are the fixed point or invariant points of the transformation? This is the MCQ problem. They will give that the problem, then you have to find that fixed point or invariant point of that transformation. So simply how can we solve that? Substituting W equal to Z, and then you can solve the equation. You will get that second order equation. Then find that Z value. You will get the two values of Z. The two values of Z are known as the fixed point or invariant point of the transformation. Second question. Find the invariant points. Find the invariant points. See, sometimes the question may be given find the fixed points or find the invariant points. Find the invariant points of the transformation find the invariant points of the transformation W equal to 2z plus 4i divided by 1 plus iz. Find the invariant points of the transformation W equal to 2z plus 4i divided by 1 plus iz. Now, how can we solve that? Similarly, like last problem, substituting or write the solution for this. Take W equal to Z in the equation. When you are substituting W equal to Z in the equation, we will get Z equal to 2z plus 4i divided by 1 plus iz. Cross multiple that, we will get that Z into 1 plus iz equal to 2z plus 4i. Multiple that z minus z plus iz square, which is equal to 2z plus 4i. Then what you get? Iz square minus z minus 4i. Then in case if you are divide with I everything, then z square minus z by I minus 4 by I. So I get cancel, 4 you will get equal to 0. So you will get that z square 1 by I can be written as plus I is z square plus I is z minus 4 equal to 0. Then what is that value? What is that value? Minus b plus or minus root of b square minus 4ac by 2a. So minus I plus or minus root of minus 1 plus 16 divided by 2. So what are the invariant points here? Minus I plus root 15 by 2, comma, minus I minus root 15 by 2 are the invariant points or the fixed points of the transformation. So the problem comes under the invariant points from the given equation. Just you have to substitute W equal to Z and then solving the second order equation or the quadratic equation, you will get the answer. That answer is the invariant point. Simple. And it is not the long question, it is a MCQ question only. So now we will see that problems in bilinear transformation. Write the problem. Find the bilinear transformation. That problem. Find the bilinear transformation find the bilinear transformation which maps find the bilinear transformation which maps z1 equal to 0, z2 equal to minus I, z3 equal to minus 1, onto the points, W1 equal to I, W2 equal to 1, W3 equal to 0. Respectively. Okay, listen. Now see that the bilinear transformation formula. Already you written that cross ratio formula. In the cross ratio formula only for that MCQ purpose. Now I write that one more formula for that problem purpose. Okay. In the problem you have to write this formula. The bilinear transformation. Write the formula. Don't forget this. The bilinear transformation is actually the bilinear transformation is W equal to AZ plus B divided by CZ plus B D, where AD minus BC is not equal to 0. That is a bilinear transformation. We are finding that bilinear transformation by using the cross ratio formula. What is a cross ratio formula? Easily we can write. Now listen. W minus W1, W2 minus W3. Don't compare with that cross ratio formula whatever I have given already. That is totally different. This is for that problem purpose. Okay, fine. W1 minus W2, W3 minus W4. Not W4, only W is there. Instead of W4, we have to write only the W here. That is equal to whatever we have written that left hand side, the same thing in the right hand side, only substitute W equal to Z. W equal to Z. Okay, so Z minus Z1, Z2 minus Z3. Then what is the denominator? What is the denominator? Z1 minus Z2, Z3 minus Z. Z3 minus Z. Now listen. In case you can imagine in first term W in case 0 is there here. Simple. Now listen. Here in the first term in case if it is, imagine 0 is there. Simply we can remember here, don't put 0, but 0, 1, 2, 3, 1, 2, 3, 0. Down. Denominator. 0, 1, 2, 3. Denominator 1, 2, 3, 0. Similarly Z. 0, 1, 2, 3. Denominator 1, 2, 3, 0. Easily you can remember this. Is it not? Now you have to substitute all the points in the formula. Substituting W and Z value. Substituting W and Z values in the equation. Substituting W and Z value in the equation. Then what you get? Listen, W1, W2, W3 is given, Z1, Z2, Z3 is given. Okay, keep it W as W only, Z as Z only. Okay, so first term is W minus W1 is what? W1 equal to I, substitute. Then what is W2? What is W2 here? W2 1, W3 0. Okay, divided by W1 1, W2 W1 I na, I, W2 is 1, I minus 1, then W3 is 0 minus W1. See, W keep it as W, remaining things given in the problem. W1, W2, W3 given in the problem. Okay, that is equal to, keep it z as it is. Z minus z1. Z1 is what? 0. And then z2. Z2 is minus I. Z3 is minus 1 plus 1 na? Plus 1 divided by z1 minus z2. Z1 minus z2. 0 plus I. Okay. Then second one na? Z3 minus z. Z3 is minus 1 minus z. Okay, fine. Now you have to convert this form into what? What is the format? W equal to AZ plus B divided by CZ plus D, but AD minus BC is not equal to G. That format you have to convert. How to convert this? Simplify. Solving this equation, simplify this one. How to simplify? W minus I into 1 na? W minus I. Okay. In the numerator. Denominator minus W is there. I minus 1. So I minus 1 can be written as 1 minus I. Yeah. Keep it that minus as plus equal to Z minus 0 is there. Z. And then 1 minus I once again. 1 minus I divided by plus I is there. Minus 1 minus Z is there. So take it minus outside. 1 plus Z. And then outside minus I is there. Cross multiple that 1 minus I here. W minus I by W equal to Z into 1 minus I. One more 1 minus I is there. 1 minus I whole square. Divided by minus I can be write as 1 by I can be 1 by I can be written as minus I. Yeah. Minus 1 by I can be written as plus I. So I can write that I here. Denominator is what? 1 plus Z. Now what is 1 minus I whole square? 1 minus I whole square. 1 minus I whole square. 2y, yeah. 2y. So you have to write 2y whole square. Sorry, 2y only, na? 2y, already I is there. Minus 2z. Minus 2z divided by 1 plus z. And then w minus I by w is there. How can we write the w minus I by w? W minus I by w. This can be written as w by w minus I by w. That means 1 minus I by w. Okay, fine. That minus can be taken to that side or this can be taken to that side. That means we can write that as 1 plus 2z divided by 1 plus z. Keep it that minus I by w this side plus I by w. Okay, fine. Cross multiple this 1 plus z plus 2z divided by 1 plus z equal to I by w. That implies 1 plus 3 z. 1 plus 3 z divided by 1 plus z equal to I by w. But we need that w in the numerator. So w by I can be written as 1 plus z divided by 1 plus 3z. Okay, but we need only the w. W equal to I into 1 plus Z divided by 1 plus 3Z. And then you have to verify AD minus BC is not equal to 0. If it is true, means this bilinear transformation is correct. Okay, so how to do that bilinear transformation from the given problem? From the given problem, first you have to write the cross ratio formula, then you have to substitute all the values in this, then simplifying that equation, we will get that equation in the format of W equal to A Z plus B divided by C Z plus D format. That is a bilinear transformation. Okay, in case if they asking that invariant point, if they asking that invariant point of the transformation, then substituting W equal to Z here, then solving this equation, then values of Z are that invariant points or fixed points. Okay, fine. That is the first problem. Next problem, fourth question. Find the bilinear transformation. Find the bilinear transformation. Find the bilinear transformation which maps the point, which maps the point. Find the bilinear transformation which maps the point, which maps the point z1 equal to infinity. It is more important problem. Z2 equal to I, Z2 equal to I, Z3 equal to 0 onto the points, onto the points W1 equal to 0, W2 equal to I, W3 equal to infinity respectively. Listen, in the last problem all the Z values and W values are finite. Okay, here two points are infinite. One value of Z, one value of W are infinite values. Then if infinite is given, if infinite is given, then how to find the solution for this? How to find the solution for this? Write the bilinear transformation formula. Write the solution. Write the solution. The bilinear transformation is, write the formula. The bilinear transformation is the bilinear transformation is, what is the formula? W minus, easily you can remember na, W minus W1, W2 minus W3 divided by W1 minus W2, W3 minus W equal to Z minus Z1, Z2 minus Z3 divided by Z1 minus Z2, Z3 minus Z. Okay, fine. Now we will see that W, keep it that, minus W1. W1 is 0. W2, W2 is I minus W3 is infinity divided by W1 is 0 minus W2 is I, W2 is I, W3 is infinity minus W equal to Z minus infinity, Z2 minus Z3, I minus 0 divided by Z1 minus Z2, infinity minus I, then 0 minus Z, 0 minus Z. Now we have to convert into that W equal to AZ plus B divided by CZ plus D format. Na? Now listen, here in case infinity is given, then you have to take that infinity outside. In case infinity is given in any one of the point, take the infinity outside. That means W minus 0 is W into if you are taking that infinity outside, what you get? I by infinity minus 1 divided by minus I. Here also taking infinity outside, 1 minus W by infinity equal to, in case if you are taking that infinity outside, Z by infinity minus 1 and then I divided by taking that infinity outside, 1 minus I infinity minus Z. Okay, fine. See, we know that I by infinity 0. Here you can imagine you are cancelling that infinity here. Infinity by infinity cancel. Okay. Now listen, I by infinity 0. W keep it that 0 minus 1 divided by minus I and then 1 minus 0 equal to Z by infinity 0 minus 1 into I divided by 1 minus 0 into minus Z. Then simplify this. What do you get? W minus 1 minus W divided by minus I equal to minus I divided by minus Z. Here W minus minus get cancelled, here also minus minus get cancelled, and then W equal to minus 1 by Z. Infinity by infinity is indeterminate format. Indeterminate form. Listen, we can't able to prove it is equal to 1, but approximate equal. Fifth problem. Find the bilinear transformation. Find the bilinear transformation. Find the bilinear transformation that maps the points minus 1, 0, 1 in the Z plane in the z plane. Find the bilinear transformation. Find the bilinear transformation that maps the points -1, 0, 1 in the z plane into the points into the points into the points 0, I, 3i in the w plane. Write the solution. The bilinear transformation is the bilinear transformation is w minus w1, w2 minus w3 divided by w1 minus w2, w3 minus w equal to z minus z1, z2 minus z3 by z1 minus z2, z3 minus z. Okay, now substitute the values here. Substitute the values here. W minus W minus 0. Then W2 is I minus 3i. Denominator W1 is 0 minus I, 3i minus W equal to z minus plus 1, and then z2 is 0 minus 1 divided by z1 is what? Minus 1 minus 0, z3 is 1 minus z. How can we simplify this? How can we simplify this? W minus 0 is W minus 2y. So minus 2y W divided by minus I, 3i minus W equal to z plus 1 minus of z plus 1 divided by minus of, so z minus 1 we can write now, minus is there, minus, okay, 1 minus z we can write here, already minus is there, that minus minus cancel here, so we can keep it as plus here. Minus 1 get cancelled, so z minus z plus 1 divided by 1 minus z, 2y W is there. Now listen, in the last problem, in the numerator W minus 1 is there, so we can easily write the answer for this. Now we are not able to simplify like this. Now we have to cross multiple. Cross multiple separating W and Z. Separating W and Z. Now write down minus 2yw into 1 minus z. So we can keep it plus here, z minus 1 equal to z plus 1, and then multiple this minus I, 3i minus w minus wi minus 3, yeah, plus 3 wi plus 3 na, I square is there, I square wi plus 3 na, Okay. Now simplify this. So 2y w z 2y z minus 2y equal to w z I 3z plus wy plus 3. How to simplify this? Keeping the w one side, keeping the z other side. That means 2y is a 2y So 2y is a w z I is there na? Then I z one time, and then minus 2y plus wy is there. Keep it to that side, minus 3iw. Remaining things are 3, take it outside, z plus 1. Then w take it outside. W take it outside. I is at minus, I is at minus 3i equal to 3 into z plus 1. So w equal to 3 into z plus 1 divided by I into, it is a bilinear transformation. So listen, solving method is not same for all the problem. Only formula is easy. The other thing you have to practice it, then only every problem is different solving method. In the first problem, simply you are solving. Second problem, both the side infinite is there. Then third problem, you are cross multiple that. Last one is fifth problem. Huh? This one is sixth problem. Sixth problem is find the bilinear transformation. Find the bilinear transformation. Find the bilinear transformation which maps the points. Find the bilinear transformation which maps the points, z1 equal to 1, z2 equal to I, z3 equal to minus 1 into the points w1 equal to I, w2 equal to 0 and w3 equal to minus I, w3 equal to minus I. Respectively. The bilinear transformation is, write the solution for this. The bilinear transformation is, write the formula. W minus W1, W2 minus W3 by W1 minus W2, W3 minus W equal to Z minus Z1, Z2 minus Z3 divided by Z1 minus Z2, Z3 minus Z. So if you are substituting this value, then what you get? W minus I 0 minus 0 plus I divided by I minus 0 minus I minus W equal to Z minus 1 to I plus 1 divided by 1 minus I minus 1 minus. Simplify this. Simplify W minus I plus I into W minus I into W minus I divided by once again minus I into taking that minus outside minus I plus W or W plus I. So that is equal to, here remaining is Z minus 1 into 1 I plus 1 divided by 1 minus I minus, take it outside fully, 1 minus I and then 1 plus Z. Is it not? So here minus get cancelled. Okay, now listen. So here all the previous problem, either in denominator or numerator, only one W is there. Here see that both in the numerator W minus I plus W is there. If this type of problem is come, then using CD rule, here how to use the CD rule here, A by B equal to C by D means that is equal to, okay na. So now you have to do that both the sides. We will get that. We can write that IW minus I will check it once. Array, in the numerator and denominator II is there. No? II get cancelled. Okay. Then only W plus I, W minus I, W plus I is there. Okay. So W minus I plus W plus I divided by W minus I minus W minus I, which is equal to Z minus 1 into I plus 1 plus 1 minus I 1 plus Z divided by Z minus 1 I plus 1 minus 1 minus I into 1 plus Z. Then what you get? Here minus I plus I get cancelled, 2W divided by W get cancelled, minus 2I, which is equal to, multiple this, Zi plus Z minus I minus 1 plus 1 plus Z minus I minus IZ divided by, same thing na, Zi plus Z minus I minus 1. Then whatever you have written here, you have to write minus na. Plus 1 is minus 1 minus Z plus I plus IZ. Is it not? Okay. No, adding numerator and denominator, numerator by denominator is CD rule is numerator plus denominator divided by numerator minus denominator. That is w minus I is the numerator, w plus I is the denominator. So adding numerator plus denominator divided by numerator minus denominator. Similarly, do the same thing for that right hand side also. Now we will get the 2w by 2i, 2 get cancel here, then w by I, w by minus I, which is equal to zi get cancel, then plus 1 minus 1 get cancel, then 2z minus 2y, 2z minus 2y divided by, here z get cancel, minus I plus I get cancel, then 2 z I minus 2, then w equal to what? Cross multiple that minus I here, minus I, 2 take it outside, z minus 2, two into z minus I, yeah, divided by taking 2 outside, zi minus 2. So you will get that multiple that minus I inside, zi minus. So what is the answer for this? They are writing 1 plus I is at, but the book answer is different. 1 plus I is at they get. No, up to that it is correct. 2 is at minus 2y. That is correct. 2i is at minus 2 is there. Minus of w by I also correct. Where? Which one? Actually, you should get that. Up to it is correct. But book answer is w equal to, verify this, 1 plus I is at divided by 1 minus I is. Need to verify. 1 minus I z we will get. Okay. Okay. 1 plus I z only we are getting. Here, how they are do is, listen. Here, minus I, z minus I divided by, here taking minus outside, then 1 minus zi, 1 minus zi, that minus minus get cancelled, then multiple here, I is at plus 1 divided by 1 minus I is at. Okay, fine. Okay, write down. Find the bilinear transformation. Find the bilinear transformation. Find the bilinear transformation. Write the problem. Bilinear transformation which maps, find the bilinear transformation which maps z1 equal to 0, z2 equal to minus I, z3 equal to minus 1 onto the points onto the points the same problem we have done. W1 equal to I, W2 equal to 1, W3 equal to 0, respectively. Find the bilinear transformation. Find the bilinear transformation that maps the points that maps the points z equal to 0 minus 1 I into W equal to 1 0 infinity. Please make note down these problems.